And welcome everybody to the Saturday night edition of the Daily Space Weather. We're going to be shortening things up a little bit because, well, it's because I'm pressed for time. So we'll tell you all about what's going on with the closest star, CMEs, coronal holes, solar flares, filaments, and more here at the Smash News Network, least busted name in news. Let's get to it. Here's the past 24 hours from the closest star, the Solar Dynamics Observatory. You might see a dark feature there, right in the Earth-facing portion of the solar disk. That's a coronal hole, an area of the sun's atmosphere where there is a bit of a shortage of certain elements. In this case, a shortage of two different species of ionized iron. And let's take a brief tour from north to south. So some filamentary activity up there in the northwest. That's the upper right of your picture. And mostly stable as far as the past 24 hours. No major changes going on. No major sunspot degradation or growth. We've actually seen a dip in the sunspot number a bit unexpectedly, as some sunspots have shrunk and then regrown. We'll get to it. First, the southern polar view. And let's talk about the channel. If you'd like to support the content, become a member of the Smash Team. Smashomash.com/Smash Team. We launched our own subscription services site because Patreon could not contain the content. We needed more capabilities, so rather than continue with Patreon, we still are on Patreon, by the way, but Smashomash.com/Smash Team is where to get the additional content. So visit the links below the video, support the channel, and increase the probability these videos will continue to exist, remain publicly visible, and free for all to view. You can find links at Smashomash.com to all of that sort of stuff. Hit us up on social media. Don't forget to press the like button. If you're new to the channel, don't forget to press subscribe. Treat yourself to the world's most comprehensive daily space weather content and most detailed solar imagery you'll find in the known universe. Today's featured product is forgive, remember, and hold accountable. Because, folks, holding a grudge is like ingesting poison and expecting the other person to die. So don't do it. Forgive, remember, and hold accountable. That's some words of wisdom here from Smash Staff and I. Give her a raise. Pick up some merch. 36 other designs available on dozens of different types of products. That public service message brought to you by us at Massive Personal Risk and Expense. Links below the video to the Redbubble shop. And you can save big, by the way, on all kinds of different products, up to 60% savings. If you're looking to pick up some gear, now is a good time to do it. So here is yesterday plus today. That's November 3rd and 4th to date. And you see some sunspots degrading in the northern hemisphere and then reforming. Will they get named a different number? Well, you have to stay tuned for tomorrow's video to figure that one out, as that is a recent development. So quite a few sunspots there evaporating in the northern hemisphere. Let's check out the magnetogram for that same period. That's November 3rd and 4th to date. And before we continue on with space weather, let's continue on with some Earth weather. Volcanic Earth weather. The Reykjanes Peninsula reporting only about 900 earthquakes in the past 10 hours. Only about 900 earthquakes, all under a 3.0 magnitude. So the Reykjanes Peninsula continues to shake. Let us know in the comments if you think it's going to erupt with a major eruption in southern Iceland. Kljufskoy also producing an unknown volcanic ash plume there. Residual volcanic ash there showing up at Kljufskoy. Iwo Jima continues to build a new island, essentially, forming some pumice rafts there. The seamount volcano Iwo Jima continues to erupt, emitting some gas and ash into the atmosphere. Suwanosei Jima also producing a 6,000-foot ash plume. Tokono exploding 7,000-foot ash plume over Halmahera. Popocatépetl exploding, 21,000-foot ash plume over central Mexico. Nevado de Ruiz exploding, flight level 220. It's a 22,000-foot ash plume. Revenador, volcanic ash observed, no indication of the plume height. However, Sabancaya in Peru, producing a 24,000-foot plume of volcanic ash. Please do not pole vault the caldera. Next, headed to earthquakes. And it's been pretty calm over the past 24 hours. There are the past 90 days. And no major quakes over the past 24 hours. These are the ones of a 5 or greater magnitude. So starting out the last 24 hours, pretty calm here. Finally, a 5.0 at the Mariana Islands region. Not to be confused with the Marinara Islands, which don't exist. But the Mariana Islands are located around the world's deepest ocean trench. That 5.0 occurred at 9:38 Universal Time this morning. And that, my friends and foes, is the only quake of a 5 or greater magnitude. Next, some more space. Here's the closest star, another 24-hour video featuring ionized helium and iron, 304 plus 335 angstroms respectively. Again, it has been pretty calm. There was at least one CME, which we will cover, a coronal mass ejection, as 2 are headed this way. By the way, we are seeing geomagnetic storm conditions as well. So a little bit of an unexpected coronal hole high-speed stream looks like it's showing up, and this one might be quite significant. We may see coronal hole winds get up to like 800 kilometers per second as we have a very high-density wave ahead of that coronal hole high-speed stream. So 10.7 centimeter radial flux has dropped down a little bit since yesterday to 155 solar flux units. And let me just elaborate on what I said yesterday. Solar flux units are 10,000 Jansky of electromagnetic radiation flux density. It's a way to measure electromagnetic radiation flux density in space, and it's just basically an arbitrary thing. 10,000 Jansky, Jansky, is the radio flux. Each solar flux unit represents 10,000 Jansky of electromagnetic flux density. Anyway, the current number is 155 solar flux units for the radio flux. Now, NOAA is forecasting, it looks like it's more similar to what we called. They're forecasting geomagnetic unrest to start tomorrow night. We are expecting that to possibly last well into the 7th. So 2 coronal mass ejections headed our way. The first one to arrive late in the day tomorrow. It looks like NOAA agrees. Let's take a look at their Enlil spiral. And it looks like now NOAA is expecting it to arrive late in the day on the 5th. So that's the forecast from NOAA. Pretty well earthly directed CME there. And again, we are expecting 2, so expecting 1 to show up sometime after midday tomorrow. Here's NASA's forecast while we're at it. And NASA's forecast is looking a little bit like a similar impact there. Note the time and date stamps in the upper left. Pretty similar to NOAA's forecast. And NASA forecasted that one quite quickly. You can see a pretty early tweet if you follow us on Twitter, which you should, x.com/smashomash. Anyway, the geospace magnetosphere movies are still jacked up. Look at that. That's still Halloween. No geospace magnetosphere movies and no ground magnetic perturbations maps. They have been jacked. So no data there. Let's move on to the KP index. Again, geomagnetic storm conditions have come somewhat out of nowhere. Nobody really expected that. A coronal hole high-speed stream showing up. The density wave is here, and it's quite dense indeed. We'll get to it next. Real-time solar wind here showing a significant change in the magnetic field. So check it out, a strong negative BZ signal there. 16 nanotesla for the overall field, with a negative BZ of 12. And also a solar wind density here in the upper 20s. So actually over 30 protons per cubic centimeter there. So it's looking like a quite powerful coronal hole high-speed stream accompanied by a quite strong magnetic field. That's the ACE. Here's the Discover, and it's showing similar data there, although seeing even higher densities at the Discover, up to like 50 protons per cubic centimeter. So it looks like the leading edge of a coronal hole high-speed stream. Don't be surprised to see solar wind speeds make it up over 700 kilometers per second in the coming 24 hours. So multiple events now, all showing up kind of at once. A coronal hole high-speed stream and 2 coronal mass ejections expected to start striking by about midday tomorrow on October 5th. Next, our GOES magnetometers. What's going on with those? There you go. Seeing some rapid shifts in the magnetic field there. No real surprise, as high-density plasma is buffeting Earth's magnetosphere. That's the past 3 days of magnetometers from GOES 16 and GOES 18, and here is our top view ecliptic plane field plot. And what do we have? The South Pole current sheet is moving back. So we may see some shrinkage of those southern sunspots, folks. Those sunspots in the southeast, those might evaporate like the ones in the northeast have. We'll have to see what happens. Here's our line of sight field plot. And you can see some action happening over there on the left of your screen. That's the solar B field on the eastern limb. A little bit of magnetic indecision now happening once again like it was a few days ago. And it looked like a mini Terminator event. Looks like we may be having another one. So there you can see that blue line waving around. The north and south pole magnetism switching places over there on the east. Possibly a second miniature Terminator event is underway. So here are coronal holes. And we've got mostly south pole oriented. There you go. Only a few in the southeast of North Pole orientation. So down here there are a few hiding behind plasma. The rest of these are all south. So that sector boundary crossing is way over there, and it's looking like it's staying away for another couple of days here. That is the SDO 211 angstroms wavelength. And let's move on to sunspots. Sunspot number has dipped. And there is the Belgian Royal Observatory. Sunspot numbered back down to like 104, it looks like. 104 is the sunspot number. That's what I'll call it, 104. And here's our flare monitor and flare scoreboard. So we do still have multiple magnetically complex sunspots. I believe the likelihood of large solar flares has dipped since yesterday. Let's bring up the latest image here. There is, so let's see, this sunspot here, 3480, is now the most likely to produce a large flare. There is still a significant likelihood of a large flare over here in the western limb, as beta-class sunspots are setting over there. So this is the number 1 spot. Number 2 spot is over here on the western limb for large solar flares. And here are sunspots from SDO. Here we've included the AIA 171 angstroms wavelength to accentuate the active regions. Next we will subtract that. Here's just the SDO continuum for the past 24 hours. And yeah, that's what's going on. Those sunspots in the north, they've evaporated and then reformed. No, they haven't completely degraded though. So yeah, a bit of a dip in the sunspot number there. No forecast at the moment for sunspots, but let's take a look at magnetic fields. There is the SDO magnetogram. So not a lot of changes happening besides those north-central sunspots. And even those changes have been modest at the most. Next, we did see some minor solar energetic particle events. So let's take a look at what's going on with those. quite insignificant there. Tiny little spikes in the ghost proton flux. Now keep in mind we do have a likelihood of proton events once again now because we have a coronal hole high-speed stream impacting. The high-speed portion is not here yet, but the density wave has certainly arrived. So X-ray flux still right around a C0, or a C1 class level, I should say. Somewhere between a B9 and a C1. No major flares over the past 24 hours. Here's 94 plus 131 angstroms, SDO. The classic wavelengths. So once again, folks, the most likely place to see a large flare would be over here. That's number 1. Number 2 is this entire western limb. That's my story, and I'm sticking to it. Next, a star chart. So this is what's going on above head, Lehigh Valley, Pennsylvania. Skyandtelescope.org is the provider of that spectacular star chart. The sun has set and Jupiter has riz. I wonder where all the snowflakes is. Minnesota. Also, you can see Saturn if you're viewing the early evening skies. Next, the solar system forecast. Here's where things are today. Here's where things will be in a week. On 11/11, that'll cause some people to declare that it is now doomsday. We will have a crescent waning moon by the 11th of the 11th month. Oh no, 11/11, Jupiter's going to destroy the Earth. Next, the astronomy picture of the day. Yeah, astronomy picture of the day. You got to have it. And this one is, it's Dinkinesh, the asteroid with a small moon. So this is about 800 meters, and this is about 220 meters. The asteroid with a satellite. Anyway, again, that's the astronomy photo of the day. apod.nasa.gov. If you want to check it out yourself, Dinkinesh. And moving along to CMEs. Yeah, CMEs, they're kind of important, right? You want to know about CMEs, don't you? Don't you? Okay, well, we've got that covered. First, let's take a look at our George Mason University images, and there you can see yesterday's CME, which is headed toward Earth. That one occurring early in the day yesterday, around midday, actually. That's 95 frames from yesterday, November 3rd, and here are an additional 64 frames from today, November 4th. There's a pretty significant one coming out of the northern polar region. We do not anticipate that one to have earthly directed components. But again, we do expect 2 CMEs to be headed this way, starting to arrive midday tomorrow. Anyway, here's LASCO C2 and C3. And let's get a little closer. So pretty decent coronal mass ejection there. Pretty much not likely to be directed toward Earth. Just this side of a 0% chance of that striking Earth. So we might see some significant space weather coming in the coming days. Let's show stereo A and its difference imagery as well. That's where it's located, where that red circle is. And here's stereo A and its difference imagery. Not too bad. Let's bring that back. Nice. There's 7:09 and 5 seconds universal time on the stereo A and difference. Next are custom coronagraphs. These are 24-hour videos. And you can see Mars over there on the left. That's Mars, the red, boring, sterile planet. Here we'll zoom in a little bit closer to show you where that CME came from. It was a filament that erupted up here in the northwest, right near the polar region. And let's drop C3 and get one step closer. We'll add 304 angstroms to SDO. And there you can see that filament right there. Whoops! It is on its way out, just not toward you. And here's just 304 plus 193 angstroms. It's time to transition to filaments. Yes, filaments. Anyone could turn into a coronal mass ejection. So let's take a look at filaments from Big Bear. Lots of them on the Earth-facing portion of the solar disk. Check it out. Lots of filaments. The most massive one being the one up there in the northeast. Check that one out. That is one gigantic filament indeed. It's hundreds of thousands of kilometers in length. And let's show our viewers how to name filaments. So you pick an image. Let's actually, instead of copying, we're going to put an arrow like this. And then I'm going to take a screenshot. Right? And then we'll head to Twitter. And by the way, thanks to our 0 new Twitter followers, we really appreciate that. If you are doing social media, make sure you follow us over there. What are you talking about, Microsloth? If you want to name filaments after living people, join us over there and follow the hashtag. Name that filament. Name that filament after living humans. Would you like us to name another filament after a big tech oligarch? Well, if not, then come over to Twitter and name that filament. America's favorite pastime. Name that filament. Once again, thanks to our 0 new Twitter followers. And thanks to Elon Musk for, quote, fixing censorship on the internet. A fine job you're doing, Elon. A fine job. Everybody slow clap for Elon. Next, more hydrogen alpha imagery from Big Bear to show prominences, and there are quite a few, especially around the eastern and western limbs. Actually, those western ones look like they've collapsed or ejected, but some remain around the east. And let's take a look at some more current imagery here. Here are the past about 3 hours from the GOES 16 SUVI. Yes, and thanks for stargazing with us, by the way. Congratulations on realizing that the channel exists. So there you go. That is what's going on. It looks like there may be a new active region rising there around the eastern equator. And let's do bonus features. Satellite charging hazards. We have some. They are currently over places like India, the Middle East, and China, Vietnam, Cambodia, Korea, China, not Korea, just China. Say it like Trump, as if you have a sinus infection. Chida. It's spelled C-H-I-D-A, if you're wondering. Next, a dip in the electron flux, something that you may have come to expect by watching our channel. That is the impact of high-density solar wind. Probably turning into an erroneous reading, as the ionosphere gets scintillated. Next, the 1-year graph of the relativistic electrons. And we are in electron storm levels. NOAA expecting a further increase, but it's not going to happen. The next update is going to be way down here. So we're expecting a decrease. NOAA's expecting an increase. Make sure you watch tomorrow's space weather video to determine who was correct. Next, the F layer of the ionosphere, where it's measured, right about 300 kilometers of altitude. And there is what's shaken at the Earth-space bridge. The bridge between Earth and space, the F layer of the ionosphere. Don't try to breathe at 300 kilometers of altitude. Bring your own oxygen if you're up there, because it will not be healthy. That is space for all intents and purposes. Here's the anomalogram for that same layer. That's anomaly in megahertz from a 30-day median. High-frequency anomaly in blue, low-frequency anomaly in red, and expect to see a lot of low-frequency anomaly in the coming couple of days. because of a coronal hole high-speed stream and 2 coronal mass ejection impacts. Exciting stuff for space weather. So there's the latest image, 2215 universal time ionogram, 2215 universal time anomalygram. Here's the WAM, the whole atmosphere model, the global ionosphere nowcast, depicting electron contents on the left and maximum usable radio frequencies on the right. Cheers. We'll also show total electron content by itself. It's free electrons from about 12,500 miles down to your GPS handset. Total electron content. Here's a global view. Here's me telling Smash staff to shut up that mutt. Shut up that mutt. Everybody say it aloud. Shut up that mutt. Remember, folks, the villain in every movie calls dogs mutts. That's how you know it's a bad guy. Say it aloud, folks. Shut up that mutt. You'll feel like a tough guy by saying, shut up that mutt. I dare you. Anyway, here's the anomaly in electron content over North America. That's the anomaly from the 10-day average, and check it out. Some significant high electron counts over north central Canada. Or really, it's just central Canada. Look at that. Yowzers! A big electron content signal there. Over central Canada. Oh my God, get in your bunkers, Canadians. Just kidding, folks. The electron content is not going to kill you. Like the galaxy, the electron content is not going to kill you. I guess it theoretically could somehow. By the way, press the like button. Otherwise, we will find you and we will shame you. How else will you help us to keep these videos existent, publicly visible and free for all to view? Well, I'll tell you a way. By pressing like. Do it now, or your soul shall be cast into an ever-deepening and darkening abyss of doom, destruction, and doo-doo diarrhea dog turds. Press like. Press it. Press it. Press that button, like, and shut up that mutt. Anyway, here are the latest images of the closest star. There is the magnetogram. Here is the... Oh, check it out. A new sunspot just rose. So right there, there's that new active region I said might be rising, and indeed it has while we recorded the video. So that's what's going on. Most likely place for large flares would be remaining right here. Second most likely place over here on the western limb. Facts. There's the full disk rock back. And let's get to meteorology. Yes, meteorology. It's otherwise known as weather. And, by the way, you've reached the Smash News Network least busted name in news. Check it out. Here are the world's largest waves. And they're blasting into Spain and France and Portugal right now. So there might be some crazy sets out there, by the way. The west coast of France, seeing some 36-foot waves rolling in. However, there is an onshore wind, so those will be kind of crappy waves. Sorry if I buzzkilled you there. Some big waves here off the coast of South America. Those are not quite as big. Anyway, the point is, folks, the world's largest waves are off the coast of France and Spain and Portugal. So that's a thing. That is surface winds and significant wave height. Let's switch to surface winds all by its lonesome. There are the surface winds of the east. Here are the jet streams. Shout out to our viewers from under and from over the equator. Give us your recipe for clam chowder. Here are your jet streams of the central world. Here are the surface winds of Europe, Africa, and the Middle East. Here are the surface winds of the Western world. And as we get closer and closer to the U.S., there are the jet streams. By the way, we've had to switch back to shortwave radiation for a lot of our imagery. This is the visible satellite, which for some reason is backed up, so we're actually showing you the sunrise here for whatever reason. And let's just skip ahead to look at precipitation type. Check it out. There are snowflakes falling in Minnesota. Precipitation type from windy.com. There is where the white stuff is occurring. Also some freezing rain happening there. Yowzers! Next to your weather.gov map, these are your weather warnings from the National Weather Service. Weather.gov is the official homepage of the National Weather Service. Click your location if it's lit on the map, and we would show you some forecasts. However, they are jacked up, so we ain't giving you any. Oh, they're back. Here's a pressure and precipitation forecast from Tropical Tidbits. It's the 72-hour GFS model. You're welcome. That's my impression of Nick Burns, your company's computer guy. He'll fix your computer, then he'll make fun of you. So some additional snow coming to the Northern Rockies here. Also Canada, featuring some snow and indeed freezing rain. So there you go. There's a forecast for you. Continuing on to show lightning. Look at the South American lightning. Dag, the spring is rowdy in South America. Look at the freaking insane lightning. Brazil. No wonder Blanca was a mutant on Street Fighter II Championship Edition. Doggone. He was mutated by lightning, folks. Next, our real-time lightning map, courtesy of lightningmaps.org. And what do you got? The Eastern Mediterranean. Some significant thunderstorms there. That's a pretty strong one. That could be accompanied by damaging winds and hail, folks. Next time you hear thunder, I highly recommend you check out lightningmaps.org, powered by blitzachtung.org. It's a good time. And by the way, this video is dedicated to my late great pal and cycling mentor, Ron Wexler, in loving memory. Remember, folks, you should spend half of your time riding with people that are better than you and half of your time riding with people that aren't as good as you. The one helps to perpetuate the sport, and the other one helps to raise your game. We'll close out the video with U.S. Doppler radar. For the lower 48. Clouds and fog, depicted by shortwave radiation. Yeah, it's too late to use the visible at this point in time. And there is the water vapor map. Here's your recap. Vertical motion of the air column, clouds and fog. And there is water vapor, as in all of it, as another atmospheric river strikes the Pacific Northwest. And we close this thing out. See you soon. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.